Good morning, dear students. My name is Ferhan Mazher, and today is 15th April 2021. Right now, I am with the 11th Cambridge class, and today's task is to solve an MCQ paper. Today, we have set our hearts to solve October-November 2012 1-1 paper. This paper is paper 1, and this belongs from the zone 1. So, let's start today's paper. Okay, so the paper is showing on your screen 2012 October November 1-1 paper, and let's start. Okay, the first question which is showing on your screen, 1-year calipers read to 1/10 of a millimeter. Which reading is given to this procedure? Okay, so he's saying 1/10 of a millimeter. Let me show you what is the meaning of 1/10 of a millimeter. So 1/10 of a millimeter means 1/10 of millimeter. In decimals, it will be 0.1 millimeter. If I convert this millimeter thing into centimeter, I will have to divide it with 100. So 0.01 centimeter. The options given to me on in the paper, they are in centimeters. So that measurement will be up to 1/10 of a millimeter, which will be in centimeters, and it will have measurement up to 2 decimal places. So let's check up to 2 decimal places. Let's check what are the options available. After the decimal, two places. So here we go. B is the choice. Question number 1, B is the right choice. Question number 2, velocity is given by the change in displacement divided by the change in time. How many vector quantities appear in this statement? You see, velocity is a vector quantity and displacement is a vector quantity. Time is a scalar quantity. So there are 2 vector quantities which showed up in this statement. So C is the choice for question number 2. C is the choice. Next question is question number 3, and it says a ball starts to roll down a steep slope and then along rough horizontal ground. Which best shows the speed of the ball? You see, because it's rolling down on a steep slope. Steep slope means that it will its velocity will increase, and then it will start rolling on a rough horizontal ground. When it will roll on the rough horizontal ground, its speed will slow down. So first the speed should go up and then the speed should come down. So I think the D is the best option. Question number 2, C can be the answer, but in the C, when it touched the horizontal ground, it has stopped moving. So C cannot be the choice because it rolled along the rough horizontal road ground for some time. That's why the D is the best option. Okay, so next question number 4. A car is stationary at a set of traffic lights. When the lights turn green, the car begins to move and continues to speed up until it reaches the maximum speed allowed. It continues to travel at this constant speed for the rest of the journey. What happens to the acceleration and to the velocity of the car during this journey? You see, it was stationary, then it moved, it speed up, and then it continued with a constant speed. So it means that its acceleration was changing. The speed was definitely changing, and the acceleration was also changing. At first, it was at rest, then it accelerated, and then when it moves with a constant speed, the acceleration becomes 0. So it means there is a change in the acceleration, and the velocity is definitely changing. So both the acceleration and the velocity change, that looks the right answer. And only the acceleration changes, that's wrong. Only the velocity change, that is also wrong. Neither the acceleration nor the velocity change, that is also wrong. So question number 4, A is the choice. Question number 5 is on your screen. An aeroplane is halfway along a runway before it takes off. The arrow shows the direction of the 4 forces acting on the aeroplane. Lift acting on the wings, that will be in the upward direction. Force on the wheels from the ground, that is the reaction of the ground, that will be also in the upward direction. Weight of the aeroplane will be downward, and the thrust from the jet engines, that will be in the forward direction. The drag forces on the aeroplane are negligible. The gravitational field strength G is 10 Newton per kg. The acceleration of the aeroplane is 2 meters per second. So the aeroplane is accelerating, but it has not yet taken off. It has not took off yet. So what is the largest force? The force on the wheels from the ground, that is equal to that is the reaction force. The lift acting on the wings, and the thrust from the jet engines, and the weight of the aeroplane. So you see, the aeroplane is accelerating, so the forward thrust is more than the frictional forces which are acting backward. And but the aeroplane is not flying yet, so it means its weight is the largest force there. All the rest of the forces are less than its weight. The front wheel of a car is turned in a clockwise direction by the engine as the car accelerates towards the right. As shown in the diagram, there is a force of friction between the wheel and the road. What are the directions of the frictional forces on the wheel of the car and on the road? You see, this car is going to the right. The wheels are rotating in the clockwise manner, so they are trying to go backward. And so when they are trying to go backward, the force of friction on the wheel will be towards the right, and the direction of the force of friction on the road will be towards the left. Let me show you my work. I've done this on a, yeah, I've tried to show it. You see, this tire is rotating clockwise. The car is going to the right, the tire is rotating clockwise. So here, when it touches the ground, it's trying to go in this direction. So the friction on the tire will be towards the right, and on the road, the friction on the road will be towards the left. So a little tricky question. The friction on the tire will be towards the right, and the friction on the road will be towards the left. A little tricky question. Okay, so the direction of the friction force on the wheel, it will be towards left, and direction of the frictional force on the wheel it will be towards right, and on the road it will be towards the left. On the wheel it will be towards right, and on the road it will be towards the left. So I think C is the choice. Question number 6, C is the choice. Okay, so the masses X and Y are placed on opposite sides of a center of a uniform meter rule, which pivoted at its center. Which combination of masses and the distances balance the rule? You see, this X, its weight will be trying to produce an anti-clockwise turning effect or moment, and this Y, it is trying to produce a clockwise moment. And it will be balanced if the clockwise moment and the anti-clockwise moment, they will be equal to each other. So here 4 options are given. The weight is, the mass is given on the X and Y, and the distance is also given. P is the distance of X from the pivot, and S is the distance of the Y from the pivot. So let me show you my calculations. And the mass is given in gram. You can use this directly in the place of weight. The reason is because there are just 2 masses. So if I divide it with 1000 and I multiply it with 10 to convert it into weight. So because I will do this thing on both the sides. So the divided by 1000 on this side, divided by 1000 on that side. So that 1000 and 1000 will be cancelled with each other. And you multiply it with the G value, that is 10, and you will multiply the G value on both the sides. So that will be also cancelled. You see, normally we put the weight in the formula of the moment. So because here I have the mass, and that mass is in grams, so you have to convert it into kg, and then you have to multiply it with the G to make it equal to weight. But because you do the same thing on both the sides, so that's why you can skip that, because they will be actually cancelled. So now the formula will be mass multiplied D equals to mass multiplied D. So let me show you my work. I've done this on a paper. Yeah, here we go. So the four options are given. In each option, we have the clockwise moment and anti-clockwise moment. I have taken the mass and I multiplied with the moment arm and I got the moment. So that option, in that option, it will be balanced where the clockwise moment and the anti-clockwise moments, they are equal to each other. And you can see this happened in the third option, the C option, where the moment came out to be 4800 and 4800. So the clockwise and anti-clockwise moments are equal. In the C option, in the A, B, and D option, the clockwise and anti-clockwise moments, they are not equal to each other. That's why the beam or the rod will not be balanced. It will be balanced only in the option C. It will be balanced only in the option C. So which combination of masses and distances balance the rules? That's C. That is C. So I hope that you have understood. Question number 7, C is the right option. Okay. So here we go. A student balances a non-uniform object on a pivot. To do this, a weight is suspended near the left end of the object. Where is the center of the mass of the object? You see, let me copy it from here. I can explain it to you. Snipping tools. Okay. So let me copy it from here. And I just want to show you one thing. You see, this is the center of gravity. If I mean, this is the point where you put the pivot, and this whole thing is balanced. But the problem is here we have hung an extra weight. So the center of gravity cannot be here. If we have put an extra weight here, and this is balanced, this is trying to produce an anti-clockwise turning effect. So the center of gravity should be here. It should be here. The center of gravity must be here. Okay. What is the why I'm saying this? Because you see, then here the weight should be acting. Because this extra weight is trying to produce. You see, this is trying to produce, this weight is trying to produce an anti-clockwise turning effect. This is trying to produce a anti-clockwise. This is trying to produce anti-clockwise. This is anti-clockwise turning effect. So here, on the right side, there must be some force which is trying to produce a clockwise moment, and it has balanced it. So I think that this the center of gravity should be here at the D. So the weight, the line of action of the weight will be passing from here, and this will be producing a clockwise turning effect. And then it's possible that these two turning effects, they are equal to each other. These moments are equal to each other, and they have balanced it. So the center of the mass or the center of the gravity should be at the D. So the option is D. The option should be D. So the option should be D. Question number 8, D is the choice. Okay, on your screen, question number 9 showing up. Okay, question number 9 is showing on your screen. A spring has a length of 9 centimeter when loaded with a 200-gram mass. The extension mass graph for the spring is shown. So here in this graph, you can see we have extension on the y-axis and the mass on the x-axis. When there is no mass, there is no extension. When 100-gram mass is hung, the extension is 1 centimeter. When 200 grams are hung, the extension is 9. You see, when 200-gram mass is hung, the length is 9 centimeter. And we know that when 200-gram is hung, the extension will be 2 centimeter. So this is L, this is the extension. So if from 9 centimeter, I will subtract 2 centimeter. I can find out the unstretched length, L naught. Unstretched length will be the 9 centimeter minus 2 centimeter. Then he says the mass 200 gram is replaced with the mass 100 gram. What is the new length of it? So when you will hang, so 9 minus 2 will be 7 centimeters. So that will be the L naught. So when you hang 100 grams, you see from the graph, 100 gram means there will be 1 centimeter extension. So 7 plus 1, it will give you 8. So I think B should be the choice. Let me show you my work. I have done this on a paper also. So here we go. So you see, in when 200 gram is hung, so L is equal to L naught plus the extension. L is 9 centimeter, and the extension for the 900 gram, 200 gram from the graph I know is 2 centimeter. So L naught will be equals to 9 minus 2. So L naught is 7 centimeter. So the unstretched length of the spring is 7 centimeter. Then you hung 100 centimeter, 100 gram load with the spring, and from the graph I know that when you hang 100 gram load with the spring, the extension will be 1 centimeter. So the length at that moment will be L equals to L naught plus the extension. L will be equal to 7 plus 1, 8 centimeter. So this is question number 9. I think B is the choice. Question number 9, I think B is the right choice. And I hope that you have understood also. Question number 9, B is the right choice. And I hope that you have understood this question. Okay, the diagram shows two cubes made from the same material. One cube has same sides that are twice as long as the sides of the other cube. So here we have two cubes. Its side is x, its side is 2x, so its side is double. The weight of the small cube is W. Its weight I know. What is the weight of the larger cube? Its weight we want to find out. In your mathematics, you must have studied volumes and the capacity of the similar solids. And you know the weight 1 by weight 2 is equals to L1 by L2 whole cube. So let me show you my work. This is that similar solids. And so question number 10 is showing on your screen. W1 by W2 is equals to L1 by L2 whole cube. W1 is W, W2 is question, and L1 is X. That's the height. And L2 is 2x. So x and x cancelled, and I will take the cube. 1 cube is 1, 2 cube is 8. So I will cross multiply. So W2 will be 8W. The value of the weight of the second cube will be 8W. 8W. You must have learned this in your mathematics. Similar solids. 8W is the answer. So C is the choice. Question number 10. C is the right choice. Okay, my dear students, we are moving to the next question, and the next question on your screen is okay. A garden table weighs 40 Newton and has a top surface of area 2 meters square. It's raining, and the rain produces a pressure of 4 Newton per meter square on the table. What's the force exerted by the table on the ground? So let me show you my work. So there are two forces acting downward. One force is the weight of the table. So F1 is the weight of the table which is acting downward, and F2 will be the force in the downward direction which will be caused by the rain. It's pressure on the top of the table. So F1 is weight of the table, that's 40 Newton. And then there is a force in the downward direction due to the pressure of the rain. So I can find out that force pressure is equal to force by area. I know the pressure, that's 4. And the area is 2. So cross multiply it, and F will be equals to 8 Newton. So the total force acting downward will be the weight of the table and the force acting downward due to the rain, and that will be 40 plus 8 and 48 Newton. So the force acting downward on the ground due to the table and the rain on the table, that will be 48 Newton. 48 Newton. Hopefully you have understood this calculation. 48 Newton. Let's check what's the answer. 48 Newton. I think question number 11, D is the choice. Question number 11, D is the right choice, sir. Four syringes contain air at atmospheric pressure. The air in the all four syringes is slowly compressed. The results are given in the table. Which syringe shows the smallest pressure change? So every syringe, the P1 is 1 atmosphere. Okay. So for all the options given here, the pressure 1 will be equals to 1 atmosphere. The air is in the all four syringes is compressed slowly. They are compressing it slowly. So when you compress slowly, you do not let the temperature rise. That's why you compress them slowly, so that the temperature do not rise. So here I know the P1 value, that is 1 atmosphere. The V1 value, for example, in the first option is 50, and the V2 value is 10. By applying the formula P1 V1 equals to P2 V2, I will find out the value of the pressure 2. And then when I have the pressure 2 value, then I will check the change in the pressure. That's P1 minus P2, or P2 minus P1. That will be the change. So we are looking for where the smallest pressure is. Okay, we are looking for where there is the small pressure. The question can be also like this: where is the largest pressure change? So let me show you my working, and here we go. The my working. So on your screen, this is showing, this is my working P1 V1 equals to P2 V2, because you have not let the temperature change, because you compressed it very slowly. That's why I know that the temperature will not change. The P1 V1 equals to P2 V2. The P2 is equals to P1 V1 by V2. For all the four options, I have done the calculation for P2, and in the first option it's 2, it's 5. So the change in the pressure delta P will be equals to 5 minus 1, 4. And for the B option, the change in the pressure will be 2 minus 1, that will be 1. And for the third option, the change in the pressure, because the P2 is 16 and the P1 is 1, so the change in the pressure will be 15. And for the D option, the P2 value came out to be 4, and the change in the pressure will be 4 minus 1, and that will be 3. So we are looking, you see the largest pressure change happened in the C option, and the smallest pressure change happened in the B option. Because today in this question, we are looking for the smallest change in the pressure. That's why the B is the right option. That's why the B is the right option. Question number 12, B is the right option. Question number 12, so B is the right option. This question was little tricky, it's wording, and the style of questioning is basically easy, but to understand that what he has asked and how we should do, that's a little tricky. So question number 12, B is the option, sir. So now we are going to the next part, which is a non-renewable source of energy. A battery in a watch, that is a non-renewable energy source. Hydroelectric power station, that's a renewable. A solar panel is a renewable, and a wind turbine is a renewable. So which is a non-renewable energy source? A is the answer. It's a non-renewable energy source. A builder lifts 8 slabs from the ground onto the back of a lorry 1.5 meter high. The total time taken is 48 seconds, and each slab weighs 20 Newton. How much useful power does the builder produce? You know, the power is work divided by time. Power equals to work divided by time. And work in this case will be weight of the slabs multiply the vertical height gain. Weight of the slabs and multiply with the height. So, but the weight of one slab is 20 Newton. He lifted 8 slabs. So 8 multiply weight of one slab multiply the vertical height gained by the slabs divided by the time taken. That will give you the power. So let me check. I have done this work, and let me show you my work. Okay. So question number 14 is showing on your screen. Power is equals to work divided by time, and work is weight and into the vertical height divided by time. Because there are 8 slabs and each slab is 20 Newton, and each slab is lifted 1.5 meter vertically, divided by time taken is 48 seconds. So the power will be 5 watt. I did this calculation. The power will be 5 watt. I hope you have understood this numerical. And 5 watt, question number 14A is the right choice. So on your screen now we are showing when a gas is rapidly compressed to a smaller volume, its temperature increases. What happens to the gas molecule? You see, you have compressed it, so the volume has decreased. The molecules will move closer together, and because the temperature is rising, so their average speed will increase. So they move closer together and their average speed increases. That is the right answer. A option, they move closer together and their average speed decreases. That's wrong because the temperature has increased. And they move closer together and their average speed remains unchanged. That's wrong because we know that the temperature has increased. They stay the same distance apart. No, because we know we compressed it. When you compressed it, its volume has decreased. So question number 15, B is the right option, sir. Okay. On a hot day, the drink in a bottle can be kept cool by standing the bottle in a bowl of water and placing a wet cloth over it. Why is the drink kept cool? Because you see this wet cloth, you see that wet cloth? From here, the water will be evaporating. And when the water will evaporate, the temperature here, that will decrease. Okay? So the hot air cannot escape from the bottle. That's wrong. The cloth conduct heat from the bottle into the water. That's wrong. The drink cannot evaporate from the bottle. That is also wrong. The water evaporating from the cloth cools the drink. That is the right choice. Question number 16, D is the right choice, sir. A student uses a double-walled glass vessel to contain a liquid, hot liquid. It's talking about the vacuum flask, and the glass has double layer, and between the two layers we have space, and its three faces have been marked Q, R, and S. It says, what reduces the heat loss by radiation? The radiation can be only stopped if you have the surfaces are silver, shiny. Okay, a vacuum in the space between the walls, that vacuum cannot stop the radiation. Painting the surface cube black, no, that will be wrong because black color will be a very good emitter of the infrared radiation. Painting the surface R black, that is wrong because it will then be a very good absorber of the heat. Painting the surface as silver, that is the right option because if this outside is silver, it will not let the heat go out. So D is the right choice. Question number 17, D is the right choice, sir. What is the reason for the constriction in the clinical thermometer? The constriction do not allow the mercury to come back into the bulb quickly. To give the thermometer a smaller temperature range, no. To make the thermometer more sensitive, no. To prevent the mercury breaking the bulb when it expands, no. To stop the mercury from going back to the bulb, that's the right answer. That is the reason why we have the constriction in the clinical thermometer. So question number 18, D is the right choice. Okay, question number 19 is on your screen. Less heat is needed to raise the temperature of 1 kg of copper by 1 degree. So we need less heat for copper of 1 kg of copper to raise the temperature of 1 degree centigrade. Then it is needed to raise the temperature of 1 kg of water. So copper will require less amount of heat. That's why the temperature of the copper will rise very quickly, but the temperature of the water do not rise quickly. So which statement explains this? This happened because the specific heat capacity of the copper is lower as compared to the specific heat capacity of the water. In other words, you can say the specific heat capacity of the water is higher as compared to the specific heat capacity of the copper. So copper have lower specific heat capacity. So copper has a lower specific heat capacity. Yeah, that is the right answer. B. Question number 19, B is the right option. A person cannot unscrew the metal lid of a pot of jam. The lid can be unscrewed after it has been held under hot running water for a few seconds. Why is this? You see, when you pour hot water on the lid normally is made up of plastic, or it might be made of the tin. And when the hot water will fall on that lid, it will expand, and because the metal will expand more, and it's just made of metal, yeah. So the metal will expand more as compared to the glass jar. So what will happen? It will lose, and you can open it. So the reason is the metal lid expands. Common sense question. Question number 20D is the right option, sir. The diagram shows the pattern of waves in a ripple tank. What does the pattern show? The waves are, let me show you. Slow a little bit. This is question number 21. Let me show you what is actually happening. So let me take it to the paint. So basically is what happening here. So basically the waves are coming in this direction. Okay. So the waves are basically coming in this direction, and from this barrier they are reflected. You see, from this barrier they are reflected. From this barrier they got reflected. That's why you see the direction of the wavefronts have changed. This red line is showing the direction of the incident wavefronts, and this blue line is showing the direction of the reflected wavefronts. So here the reflection of the waves has taken place, and you know, when reflection takes place, the frequency of the waves do not change, the wavelengths do not change, the speed do not change. Only the direction of the wavefronts have changed. Only the direction of the wave changes. No change in the speed, no change in the wavelength, no change in the frequency. So this is basically reflection of the waves from a barrier. So let me show you. Okay. So what is this? This is waves being reflected. So A is the right option, sir. Question number 21, A is the right option. Here, an object O is placed in front of a plane mirror, which diagram correctly represents the image I formed by the plane mirror. When the image is formed in the plane mirror, the image is at the same distance as the distance of the object from the mirror, and the image is upright. Okay, so the image should be upright. The image is formed behind the mirror. Okay, so clearly A is the option. You see, this can be answered, but it's not upright. It has been inverted. This is wrong, and this is also wrong. So only the correct option is A. I hope you have understood this one. So let's move to the next question. He says, okay, in the following diagrams, the angle C is the critical angle. The angle of incidence is equals to the critical angle. Which diagram shows the correct path of the light ray when the angle of incidence in the dense medium is equals to the critical angle? The process of total internal reflection takes place. The light do not enter into the rare medium. It starts moving along the boundary of the dense medium and the rare medium. The angle of refraction will be of 90 degree in the rare medium. So clearly, C is the option. Question number 23, C is the option where the process of total internal reflection took place. The angle of incidence in the dense medium is equals to the critical angle, and the angle of refraction in the rare medium will be equals to 90 degree. Light will travel on the boundary of the dense medium and the rare medium. Here we go. An object of height 1.5 centimeter is placed in front of a converging lens of focal length 2 centimeter. The arrangement is shown on the full scale diagram. What is the linear magnification produced by the lens? You see, the formula for the linear magnification is the height of the image divided by the height of the object. Height of the image divided by the height of the object. You can count the height of the image. You see here you have this, so you can count it very easily. We can count it. You see, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So there are 15 small squares, and here I can count 1, 2, 3, 4, 5, 6, 7, 7.5. So divide 15 with the 7.5. Height of the image divided by height of the object. Height of the image divided by height of the object, and I got those numbers by counting the small squares. So it's very easy. You see, you will get the linear magnification. Let me show you my work. I've done this. Okay, so magnification is equal to the height of image divided by the height of object. So 15 divided by 7.5. So the magnification will be 2. So the linear magnification will be 2. So it's 2A is the option. Question number 24, A is the right option, sir. Red and violet are the colors at the ends of the visible spectrum. How do the frequencies and the wavelength of these colors compare? You know, I can show you. Do you remember that coding? The code is red, orange, Roy, G, Biv. Okay. So as you go in this direction, as you go in this direction, you know, the frequency will increase. The frequency that will increase. And if you go in this direction, if you go in this direction, the wavelength that will increase. The wavelength. It means that the red will have the higher wavelength and the violet will have the higher frequency. The red will have the higher wavelength, larger wavelength, I mean, and the violet will have the higher frequency. So the higher frequency violet will have and the longer wavelength red will have. C is the question number 25. C is the right option, sir. Okay. So a vertical wire passes at right angle through a piece of card. There is a large current in the wire in the direction shown. The plotting compass is placed on the card, which diagram shows the direction in which the needle of the plotting compass points. You see the current is going downward. If the current is going downward, by using the right hand rule for the straight conductor, right hand, take your right hand and because it's going down, current is going downward, I will hold the conductor in my right hand in such a way that my thumb is pointing and it's along the direction of the conventional current. Then the curls of my finger, they are telling me the direction of the magnetic field around this conductor. So when I apply this right hand rule of the straight conductor on this conductor, the curls of my finger tell me that the direction of the magnetic field around here will be clockwise. It will be clockwise. So let me show you. So the direction of the magnetic field here will be clockwise. So let me show you my work and then how we decided it. So the direction of the magnetic field around here will be clockwise, it will be clockwise. So clockwise means that the direction of the magnetic field will be clockwise, like this, like this. The magnetic field around this conductor will be circular, and because the current is going downward, I know that the direction of the magnetic field around this straight conductor will be clockwise. And where you have plotted the compass, the direction of the magnetic field will be in this direction, So the pointer of this magnetic compass should point in this direction, towards left. So let me check. What do we have here? Towards left. C is the option. Clearly, the C is the right option. Question number 26C is the right option. I hope that you have understood that how I use the right hand rule for the straight conductor, and I decided that what is the direction of the magnetic field around this conductor, and then I decided where you have put the magnetic compass, where the pointer of that magnetic compass will be pointing. The magnetic compass pointer always align itself along the magnetic field present in that location. So C is the choice. A positively charged rod is brought near to an isolated, uncharged conducting sphere. What are the charges on the side X and Y of the sphere? So on this X, we will have the negative charges, and on the Y, we have positive charges. X is negatively charged and Y is positively charged. I think D is the right option, sir. Yes, sir. 27, very easy question. D is the right option. A very easy question. Three identical cells are connected in parallel to a resistor. What is the advantage of using the three cells in the parallel rather than a single cell? Each cell produces more energy. That's wrong. Each cell supplies more charge. No. Each cell takes longer time to run down. That's right. The total electromotive force is larger. No, no, no. So C is the right statement. Okay. The diagram shows three resistors in parallel. What is the combined resistance? You see these three resistors. They are connected in parallel with each other, so I can find their equivalent resistance. I have done this on a paper. Let me show you my work. So because they are connected in parallel to each other, so I can find their equivalent resistance. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So it will be 1 by 5 plus 1 by 5 plus 1 by 5. So it will be 5 by 10. So cross multiply and R equivalent will be 10 by 5 equals to 2 ohm. So the equivalent resistance will be 2 ohm. I hope you have understood. Equal to 2 ohm. So 2 ohm. B is the option. Question number 29. B is the right option, sir. Which circuit contains a fuse and a rectifying diode? So fuse and rectifying diode. The diode is connected in an alternating circuit. An alternating supply is given there. So this is the diode and this is the fuse. You can see this is the fuse and this is the diode. So clearly D is the option. There's no doubt about it. 27. Question number 30. D is the option. Okay. So here we have a lamp connected to a 12-volt supply converts energy at a rate of 36 watt. How much energy will be converted in 10 seconds? The power is given and the time is given. They want you to find out the energy. Power is equals to energy divided by time. So energy is equals to power multiplied time. So the power is 36 watt. Multiply it with the time and you will get the answer. So energy is equals to power multiplied time. I have done this on a paper. Let me show you. Okay. So question number 31, power is equals to energy divided by time. So energy is equals to power multiplied time. So it will be 36 multiplied 10 and it will be 360 joules. Easy and straightforward question. Question number 31, 360 joule is the answer. So let's check. So 360 joules is the answer. So D is the option, sir. Question number 31, D is the right option. Question number 32, an immersion heater is labeled 12 volt, 60 watt. What is the current in the heater? You see the voltage is given, the power is given, and the current is questioned. You know the electric power P is equals to IV, famous formula, power is equals to IV. I know the power, I know the voltage, I can find the I will be equals to P divided by V. I've done this on a paper. So P is equals to IV. I will be equals to P divided by V. So it will be 60 divided by 12 equals to 5 ampere. Very simple. The, the current will be 5 ampere. A very simple question. 5 ampere. Oh, sorry. B is the right option. B is the right option, sir. Question number 32, B is the right option. Okay, he says each of the diagram shows a cross section through two parallel current carrying conductors. Which diagram shows the shape of the magnetic field pattern and the direction of the forces on the two conductors? You see, the dot means that the current is coming out of the page or out of the screen, and the cross means the current is going into the screen. So I can find out the. Remember, if you have two parallel conductors and the direction of the current in both the conductors is same, then they will attract each other. If the direction of the current in both the parallel conductors is different from each other, like in this case, they are supposed to repel each other. If the direction of the current in the parallel conductors is opposite to each other, they are supposed to repel each other. And for repelling purpose, in the middle, the magnetic field should be stronger, and on the sides, the magnetic should be weaker. And this should not happen. That overlapping means that there's one magnetic field of this move around the other one. It's like hugging each other. So when there will be repulsion, no hugging like this. Okay. For attraction, yes, but because here the repulsion has to take place, so no hugging diagram. So this is the right diagram. They should repel and they should no hugging each other. Okay. So C is the right option. The diagram shows a simple DC motor. What is the part labeled Q? This is called the split ring commutator. So clearly, there's no doubt about the option. This part is called a split ring commutator. The diagram shows the north pole of a magnet moving into and out of a coil of wire. The movement produces a current in the coil of wire. The current produces a magnetic pole at the X. Which pole is produced at X, and when the magnet is moved in and when it is moved out? Let me take this diagram and I can show you. Sorry. Let me take it into the paint so I can show you. So when this bar magnet, you are moving it, try to understand. According to the Lenz's law, when the north is approaching, the current produced here will be in such a direction that it will try to oppose this motion. So when the north is approaching, to stop it here, a north will appear. Okay. So now the other option, the other thing is when this north is going away. So the EMF will be induced here, and according to the Lenz law, the EMF produced will have direction in such a way that it will try to oppose the cause which is producing it. So when this north is going away, to stop this, we will have a south here. So we will have a south here. So when the north is coming in, on the X, we will have a north to stop it. And when this north is going away, on the X, we will have automatically a south to stop it. So hopefully now you understand. And let me take the, so north, when the magnet moved in, on the X, we will have a north. And when the magnet will move out, on the X, we will have a south. So clearly the B is the option. Question number 35, B is the right option, and I hope that you have understood the idea. Okay. So here we have a simple AC generator produces an alternating EMF as shown. You see the time period is 1 second and the amplitude is 1 volt. The speed of the generator is doubled, which graph dash represents the new output. When you double the speed, the voltage should also become double, and the time period should become half. The frequency will double. The time period should become half. So in 1 second, if one wave is completed, now in 1 second there should be 2 waves completed, and their amplitude should also double. So what are the options? Okay. So where the time period in 1 second, now the 2 waves should show, and because the time period has become half, and the amplitude should move from 1 to 2. So clearly, D is the option. You can see. You see, this is D. Now the amplitude has become 2, and in 1 second now you can see there are 2 waves. This was the original one. In 1 second there was 1 wave and the amplitude was 1. So when you double the speed, the frequency will become double, the time period will become half. On the same display there will be double number of waves shown, and the amplitude of those waves should be double. So that's why we have chosen D. Okay. So the next question is showing up. What is required to operate a reed relay in a switching circuit? Reed relay, a capacitor? No. An electric field? No. A magnetic field? Yes. And we use electromagnetic field. 37. C is the right choice. For reed relay, you need a magnetic field. Okay. In the simple model of an atom, X orbits around Y. So X is definitely electrons. This X is electrons and Y is the nucleus. So without any doubt, A is the choice. Very simple, straightforward. Question number. In nuclear dash, hydrogen nuclei dash to form helium. So in the nuclear fusion, hydrogen nuclei join together to form nuclei, releasing energy. Which words correctly complete the gap 1 and gap 2? So C is the right option. It's a very famous sentence and very easy. Fusion. This happens on the stars and on the sun. In this, the small nuclei of hydrogen fuse into each other, make a larger nucleus of the helium. So C is the choice. Question number 39, C is the choice. Which nucleus is produced when the thorium which nucleus is produced when the thorium-223, thorium is 9223, emits an alpha particle? Alpha particle. Alpha particles, when given out, the daughter nucleus will have 2 less proton number and its mass number will be decreased by 4. The proton number will be decreased by 2 and the mass number will be decreased by 4. So clearly A is the option. Let me show you my work. I've done this on a paper also to make your life easier. So you can see here the thorium, it gave out an alpha particle. Alpha particles is like the nucleus of helium. Its proton number is 2, its mass number is 4. The daughter nucleus will have 2 less protons as compared to the parent. So 19 plus 2, 88. And the mass number will be decreased by 4. 2 to 3 minus 4, it will be 219. So this is the option. So let me show you. You have taken the option. So A is the option. Question 40, A is the right option. So my dear students, today we have done October-November 2012 1 paper. This was an MCQ paper, and this MCQ paper belongs from the zone 1. So I hope that this video and this session is helpful to you. If this session has helped you to improve your grades, improve your concepts of the physics, kindly don't forget to subscribe to my YouTube channel. And also press the bell icon so that whenever I upload a new video, you get the notification in your YouTube channel. And also recommend these videos to your friends. So I hope that this thing has been very helpful to you. So thank you very much for being with us and have a good day, everybody, and God bless you all.